All right, we're going to go ahead and look at elimination today, which is our third method for solving a system. And so let's first fill in what is elimination right here up at the top. So we can say that this is a method. So again, this is the third method that we're using. Okay, so it's a method that solves a system by subtracting or adding, but typically we see subtracting. So I'm just going to put adding in parentheses here. By subtracting or adding the equations together to eliminate a variable. So what we're going to see is we are no longer going to need any equation to be solved for. So this method is really useful when you have nothing solved for. And so, right, because we're always going to see different types of equations, and maybe some are both solved for y, maybe one is solved for y, maybe one is solved for x. Elimination is going to be most useful when no equation is solved for, and we will talk about kind of why that this is the best one. So the first thing that we need to do is we need to make sure that my equations are lined up, meaning that my x's have to be on top of each other, my y's have to be on top of each other, my numbers have to be on top of each other at the end. We typically see them in standard form, which is ax plus by equals c. But we're going to look at one equation today where that's not the case. Then we will identify a variable that has the same coefficient on both equations. And we'll talk about what that word coefficient means in a second. We will then subtract the equations to eliminate this variable. However, sometimes you may add. It just depends on the sign, okay? Then I will solve the equation for the remaining variable. Once I find that, I will substitute into my answer or into my one of the previous equations and go from there. Again, my answer needs to be written as an ordered pair. All right, so on this first page, I'm only going to do number 1 because we typically won't see a problem like this on the examples that I give you, and I will put in on Google Classroom what homework questions that I kind of want you to skip, because I don't really like ones like number 1, because as you can see, these are both solved for y. My recommendation for this would be to graph it, okay? I would never really want us to use elimination for something like this. I would say graph it is the easiest, or you could substitute. But I do want to show you how we can still eliminate, okay? So first thing that I want to make sure is that I have my y's on top of each other, my x's on top of each other, and my constants on top of each other. We can only add or subtract equations together if they are in the same exact order. Because again, I can only add y's together, add x's together, add numbers together. So now I want to subtract. Why am I choosing to subtract here? Because y plus y, we know, gives me 2y, and that wouldn't eliminate a variable. My goal is to get something to cancel out, but we know y minus y becomes 0. So what I want to do, and I want you to write it the exact same way as me, is put that minus sign on the outside, and I want parentheses around that entire thing to show that all of this is getting subtracted, this entire equation. So y minus y is going to cancel. 9 minus x, 9 minus 1x, or really 9 minus 1 is 8x, negative 23 minus 1. Again, we are subtracting here. Minus 1 gives me negative 24, okay? And what this became over here was 0. Y minus y was 0. So here is my equation. I have canceled out a variable. I have nothing remaining over here. I subtracted everything down here. And now I can solve. So this one looks kind of weird because I have nothing over here. But if I bring that 24 to the other side, I can add 24 to both sides here. And now I get 24 equals 8x. And look how easy it is to solve now. All we have to do is divide by 8. So I find that x is equal to 3. And now all I need to do is take that x, plug it back into either equation that's already solved for y. Let's go into that bottom equation. That one seems to be easier. We can say y is equal to x, which I just found to be 3, plus 1. So 3 plus 1 is 4, so there's my y. So together as an ordered pair, we could say my answer is 3, 4. Okay, but again, that one won't really be what we see. I would not recommend elimination for that one because it can get confusing, right? We have a 0 here, then you got to remember to bring that 24 over. It can be a little confusing. So I'm going to skip this first page here because the rest of them are like that. I want us to turn to the next page and look at ones that we will typically see with elimination, okay? So let's go ahead and look at number 5. So like I said, on that first page, we're going to see ax plus by equals c more prevalently. That's going to be kind of the form that we would want to eliminate in, is whenever I have my x, then my y, and I have that equal to the constant. And so what I want to do is I want to identify what has the same coefficient. Remember, coefficient is the number in front of my x or my y. So this one is an invisible 1, this one's an invisible 1, this is an invisible positive 1, but this one is an invisible negative 1. So right now, I'm kind of looking at my x's that I want to subtract, right? I could say 1x minus 1x completely goes away. And so that's where I can say, all right, I'm going to use elimination here. That's going to be the best. So again, x minus x goes away. X minus x is 0. So we have y minus, and here's where it may also be important. That negative is getting distributed everywhere. So this negative becomes that minus x. I distribute it here, so this becomes a positive y. I even distribute it here, so this becomes a minus 7. So what you'll see me do kind of throughout this is go through and change all my signs. I'm subtracting down, okay? So I have x minus x, which goes away, y plus y, right? This was y plus y. We're subtracting a negative, so that's positive, is 2y equals 3 minus 7 is negative 4. And now all I have to do is divide by 2. So I get y equals negative 2. So maybe you're also seeing with elimination, these go a little bit faster for the first time, right? When I plug in or when I eliminate, I get an answer for y really quick or get an answer for x really quick. But I do need to plug this in for either equation now. Now here's the problem. Notice how neither of those are solved for x. That's the downfall to elimination is. Maybe it's easy to find the first answer, but you have to do a little bit of work for the second answer. So I'm just going to plug this back into the top equation, okay? So that top equation becomes x plus y. Y is negative 2 equals 3. We know a plus minus is the same thing as x minus 2 equals 3. And then I can add 2 to both sides to get x equals 5. So they would be my answer. So together, that would be 5, negative 2. So it's not an insane amount of work for the second variable, but it's usually a little bit more than what you had to do the first time. But I would say elimination, again, is really useful whenever we have two of the same thing like this. And so that's what all of today's examples will be. So let's go ahead and look at number 6. So number 6, I have 2 7s, and then I have a negative 4 and a negative 10. So obviously my eyes are going to be drawn to the 7s here. They're the same number, and I know if I subtract 7 minus 7, that is going to go away. So I can do 7 minus 7, and when I write that negative, I'm going to go through and make everything a negative, change all of those signs. So this negative is going to become a positive, and this becomes negative 25, right? I'm subtracting that entire bottom row, so we want to change that entire bottom row. So 7 minus 7 turns to 0. Negative 4 plus 10 is 6y. Negative 11 minus 25, because again, we're subtracting all of these things. Negative 11 minus 25 is negative 36. And so now we can just divide by 6 on both sides. So I get y equals negative 6. There's my first answer. Now I can plug this into either equation. I'm just going to plug it into the top equation because, again, neither of them are solved for x. And that's how it's always going to be. I'm never going to have it solved for x, so I'm going to have to do a little bit of work this second time around. So I get 7x minus 4 times y, but I just found y to be negative 6 equals negative 11. And now this is where we kind of get that algebra back like how we did with substitution. So I have to do a little bit of work here. So negative 4 times negative 6 is positive 24 equals negative 11. Then I can subtract 24 from both sides. So I get 7x equals negative 35. And then I can divide by 7. So I get x equals negative 5. So there would be my final answer. We want to write this as an ordered pair. Negative 5, comma, negative 6. All right, let's try that again. So number 7, we are going through and we're looking at my coefficients. Remember, my coefficients are the numbers in front of my variables. So I'm looking for the ones that are the perfect match. So I have a -2 and I have a -2. So that means my y's will cancel. -2 minus -2. So let's really think about this. If I'm subtracting all of this, then I'm really subtracting a negative, so that's a positive. I'm subtracting a -2y, that's a positive. I'm subtracting 5, so we make that negative. So I'm going to go through and change all of those signs. That's so important to do. Change all of your signs. So we have 4 plus x. 4x plus x gives me 5x in total. That's an invisible 1. -2 plus 2 goes away. That's what I wanted. -30 minus 5 is -35. So then I can divide by 5 on both sides. So I get x equals -7. So again, I can plug that into either equation. Let's maybe plug it in. I'm just going to keep plugging into the top one. It doesn't really matter. So we have 4 times -7 minus 2y equals -30. So 4 times -7 is -28 minus 2y equals -30. And then I want to add 28 to both sides. Again, we're always moving that number that is being added or subtracted first. So I have to do the opposite there and add 28. So I get -2y equals -2. And then I do my division second. So now I divide both sides by -2. And -2 divided by -2 is +1. So my answer here would be -7, 1. All right, let's look at number 8. Hopefully you're seeing kind of what variable we should cancel. Hopefully you already have that in your mind. Hopefully you were thinking of the y's. Both of them have a +2. So I know if I subtract down, I will get 2 minus 2, and those y's will cancel out. So again, I want to subtract, so that's a -4x minus 2y plus 18. Because we're subtracting that -18, that becomes +18. Okay, so we have 5 minus 4, which is 1. 2 minus 2, that cancels. -25 plus 18 gives me -7. So we're at the point now where I don't even have a number in front of x. So technically we're solved for. So sometimes we get confused with this and we don't know where to go, but that's my answer. X equals -7. So I'm good. I don't even have to divide by anything. That's just my answer here. So now I can plug that back in for either equation. I'm just going to plug it into the top one. You can definitely do the bottom one. There's no wrong answer here. I just always like to go with the first one that I see. So I get 5 times -7, because that's what I just found x to be, plus 2y equals 25. So 5 times -7 is -35, plus 2y equals 25. So now I can do my adding or subtracting. So I want to add 35 to both sides. I get 2y equals 25 plus 35. Oh, sorry, that was a -25, if you're wondering what I did wrong there. So 2y equals 10. -25 plus 35 is 10. And then I want to divide by 2. So I get y equals 5. And so there would be my second answer. So together we write that as -7, 5. All right, I'm going to skip number 9. I feel like we're getting the hang of it with those 4 there. And then let's go ahead, so I'll cross that out. And then let's go ahead and just jump to number 10, because this is a special equation. And you may notice that it's special because look at what's going on here. I have 2 coefficients that are the same. I have 3's in front of my x, and I also have 1's in front of my y. So if I try to subtract this, look at what happens. I have 3 minus 3. That is going to cancel out to nothing. I have y minus y. Again, we're subtracting that entire bottom row. Y minus y also goes away. 9 minus a -4, that's a +4. 9 plus 4 equals 13. And so right now I have something weird over here. I have x minus x, 0. Y minus y, 0. So there's really nothing over there. Everything canceled. Very similarly to how we did that first equation, right? I didn't just get rid of one side of my equation. I still have 2 sides, but if everything cancels out over here, I write 0. But because I have both of my variables canceled, my x's and my y's, I have 0 equals 13, which is false, and therefore no solution. Now you may have them cancel and get all real numbers, if these numbers are exactly the same, so if all of my numbers are exactly the same, then it's the same equation, right? And we know that that's the same line, and it's all real numbers. So that finishes out our notes for today. Again, please check Google Classroom for which ones you are not going to do on your homework. I have posted that in with the answers, so please don't do more work than what you need. And my bonus for today, I currently have the Clemson versus Baylor game going on my TV right now, and I had to pause it because it was getting interesting. So let me know who you have winning in your March Madness bracket, or if you don't have a bracket, just tell me who you think is going to win for an extra bonus point. So have a great day. Again, check that homework for what problems you're not doing. Let me know if you have any questions.